good?
Oh, okay, ainda não. Peraí. Não. All good. Okay. So, man, how we doing?
Doing fine.
Ok. Deixa eu chegar mais aqui. Tomar um lanche. Aí tá top. Certo. So, man, you nervous?
Nah, man. I mean, just trying to learn something.
Cool. It's the first time where I have somebody else over and sees me doing this in real life.
Sure, yeah. I mean, I caught a few streams before, but being in front of the camera is certainly different.
Oh, that's fuck. Man, so, yeah, I'll be hella awkward sometimes, but push through, you know?
Hey, I think we're together on that one.
Cool, dude. So, what we want to do today, you told me, oh, okay, wait. I'm gonna show something. Why we started all this. I'm fetching something. Just a second. Where is it again? Boom. Fortunately, we only show this screen.
Thank God. If people were seeing the image we set up for our group chat on WhatsApp, they'd be judging us at the very least.
This one. Search for the guitar. Where's the guitar with the light?
Oh, it's maybe a little bit. Oh, there it is. Yeah.
Got it. Okay, it didn't work out. I was gonna show you, but you have a guitar, and we made a stand for the guitar, and it lights up your stand.
Yeah, so I have a light that is not connected to it. I just repurposed it for that, and then I thought that maybe it would be cool just to learn a little bit more from that, to learn how to use hardware and stuff, how to mess with it. I thought we could make an actual light for it with a remote, perhaps.
For sure, man.
Yeah.
And so that involves two things. We have to make lights light up, and lights light up when we click a controller or something like that. So it's two parts: the lights lighting up and the controller controlling stuff. So I don't have the beautiful stand for us to do, but we're gonna learn all the basics with very with the principles, you know. That's it. Cool. So I prepared I prepared some cheat sheets here. So first, what I wanted to show. Oh, by the way, you don't know anything about electronic, right?
Not too much, no.
Okay, so I separated everything, so it's not that hard to understand. So if you wanna open the box and take things out, tell me what you think they are and everything.
Okay, so I assume these are some type of cable.
Yeah.
Okay.
All this science stuff.
What is this? I don't recognize this this jack. What is this for? It's just USB.
I don't think you use that actually.
Oh, okay.
I already put one here.
All right.
So it's already connected there.
Cool.
Just take it all out. So, lay out.
All right, so we got some type of orange stuff and baggies. Very doubtful looking baggies. And okay. Should probably make some sort of nice looking spread here. Okay, so we got some wires and some tweezers.
Cool. So we need to all of the Jesus, man, I cannot speak. So what we're going to do here today is program the Arduino. You know what an Arduino is?
I have a basic notion, but I feel it would be cool to learn from someone more experienced what exactly it means when we're referring to an Arduino.
Arduino is just like it's called a microcontroller, but microcontroller is usually it's this one. If you wanna take it out, take a look. So it's just a man. I am too to teaching formal nervous mode. I will just try to be chill and talk normally. It's because we usually talk in Portuguese, you know, and speaking English, it just feels...
It's about a 50-50 mix between English memes and our native language, which is weird, but we'll try to make it work somehow. It's weird to just default to one. Anyway, so this is like a circuit, right?
Yes. So a microcontroller is like brains, electronics, but with brains. You know, you can give programs and it will like take inputs and output stuff. You know, we have microprocessor and microcontrollers. Processors process stuff, and microcontrollers, they control stuff. So they can receive they can receive data from sensors and perform actions with motors, actuators, and all that stuff. You know. So the Arduino is this. Basically, this is the microcontroller. This part here.
Okay.
It's just that. The whole rest of the board is just an easier way to interact with it. So you see these holes here is where we can connect these little things. They are called jumpers, and we can get signal from them.
Cool.
So if we have a LED, boom, science. If we have an LED, it lights up when we pass current, right? So if we connect this to the negative side, but don't connect the positive side, it will stay turned off, right? And if we use the voltage from here and light the other side whenever we want, like I want to clap my hands and it will light up. It's because we give a high current, a high signal on the other side. Okay, so we just have to tell the Arduino when to do that, and we can program that. So anyway, the microcontroller is just this, and the board is an easier way to interact, because usually we would have to solder this to a board and then solder the terminal to the LED and put the resistors in the circuit. So we don't have to do that here. We have this easy accessible little holes. We can interact with it with a USB. Usually you would have to program the microcontroller with a specific adapter, and once you program you can't easily change it. So we have USB interface, so it's very easy, very fast. You can do it a lot, so you iterate very fast. You can power it with this DC jack here. So usually to power this chip is very complicated. So you see, it's just a board that facilitates you interacting with this little
it's
guy.
got all the components you might need for whatever. It's cool. Yeah, it's a little less mystical now.
Yeah, when you realize that it's just a shield for this little brain guy here, you know. So the Arduino Uno is the most famous and popular one. Because it's very easy, but there is many other types of Arduinos depending on the utility that you want to do. So this is the micro. It's very small, consumes very little power, but is harder to program. But it doesn't have as many GPIOs. These holes here that we said, this here, they are the GPIOs. So general purpose input and output. You can use it to input and output data. But it's smaller. This other guy here doesn't have USB, but it's thinner, but you have to program it using a specific converter from USB to serial. And this is the Mega. It's a big guy, have many GPIOs, but it's bigger and consumes more power, you know. So all of them are the same thing. Pedro's cool. Fred is here. So all of them are basically the same stuff, the same thing, a microcontroller, but they have different characteristics and specifications. You know, all of them you program with the same stuff, man. It's amazing.
It's the same sort of wireframe common to all of them. It's just you have some more design for sometimes. So for an LED light up, we would only need one of these. Like, what would be overkill in this case? if I were to buy one online, knowing nothing of this, what should I look for when I want to make something light based like we're doing today?
The Uno is very
Just the most basic I can find because it's just about lighting.
Yeah, you would buy this one or this one if you were doing something more specific. You know, oh, I want to make a tiny watch that I can use on my wrist or something you're going to wear. Then when you would use this one, but the other ones are easier for prototyping.
Sure.
Okay. Cool. So, and this other guy, by the way, you see that circuits, they are all in boards, so you have to solder solder. You have to solder stuff, but that takes a long time, and if you want to change, you made a mistake, it's hard. That's when we use this guy here. It's called a breadboard or a proto board because it's used for prototyping. You know, so we are going to build the circuits on that because then we don't have to solder, and you can use these jumpers, it's what we call them, to change the current to change the signal around, you know. So there is this picture here. It shows how a breadboard works. So you see ours is like this, right? And all of these holes in the horizontal are connected. So all of these blue ones, they are connected. See? And all of the red ones are connected like this. Boom, 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 boom. And in the middle part, all of the holes are connected vertically, and they are separated by this big line. So all of these holes are separated from these ones. Okay. All of the blues are connected. All of the reds are connected. And all of these ones are vertically connected.
Sure.
Easy enough, right? Cool. Then, nice. That's it. Easy.
All right.
Okay. So, what we have to do to accomplish what we want is first light up an LED whenever we want, and then get the signal from a remote and use that to light up the LED. Right? So it's two components. First, the simpler one, we can light up the LED, and I preparated.
I see you are a man of Portuguese as well. Let me just take this little girl out of the way. Okay.
Thank you, man. So I made I made two files for you. The first is Miguel's cheat sheet, and the first is Miguel's starter sketch. We're going to start on the starter sketch, and if we want to cheat, we're going to use this one.
Sure.
But it's more for this guy here is the sensor we're going to use for IR, and it dumps out the button clicks that we got in hexadecimal.
Cool, okay. That's what we're going to use to give it the signal for it to light up then.
Yes, but the problem is that hexadecimal is not very useful for us. We can say, oh, I want number 6 to say that we will light up the LED, but we don't know that. So I have some code here that just takes the hexadecimal value and converts to the button that was clicked.
Okay.
No, there was a controller somewhere. No, right? I think it's here. Boom. Forgot about this one. So the code here, it's just that it takes the hexadecimal from the receiver and shows us the number that we click there instead of that weird value.
Cool, okay.
Then, go ahead. Now it's with
Okay,
you.
so we'll begin with the sketch.
I will switch places with you. No, you can stay sit. I will just be on this side. Cool. So you used Open Frameworks before, right?
Yes, I played around with it. Should I? No.
You can make it big. Cool. So remember that in Open Frameworks you had the idea of setup and loop. In setup you preparated what you wanted before, and loop it continuously ran. Okay, we have the same here. You see there on the first line we have let me do this. I think this will be better. Sketch. Boom. 24.
25.
Nice. Okay, way better. Okay, so in the first line we have define test LED equals 13. Very comprehensible, right? We are defining a variable and calling the we're defining test LED. Very comprehensible. I'm assuming stuff. I won't do that.
Sure. No, but yeah. Let's just, for the sake of whomever might be. I mean, yeah. For us, maybe a define is easy to understand. I don't know. What is your key demographic here? People who haven't learned yet, or people who are more familiar with it?
That's a good question.
Let's just explain everything. Okay. So anyway, we got that variable you were saying.
Yes, because you work with programming, and I know that, so I suppose that. Anyway, so we define test LED as the number 13. On the setup, we do some stuff. On the loop, we do some stuff. Okay. What we do on the setup is serial is the type of communication that we do over USB, Universal Serial Bus, USB. So we just say that we're going to start on the 9600 baud rate is the speed that the serial communication is done. It's not relevant, it's just the frequency that you are, like on a television.
Okay.
You know? Not the same.
How did you arrive at this number specifically? Was this just something that you knew worked before, or like why 9600? Why?
It depends on the microcontroller.
Oh, okay. So you have to know those specifications about what you're going to work with to write this type of code.
Yes,
because I've never seen this before. Yeah.
Yes. Okay. You can there on some microcontrollers you can push faster. So you could sense something more times and make adjustments faster, but some microcontrollers are weaker and had to be slower. So we just say that we're going to start the serial communication on that baud rate. Pin mode, remember that we talked about the GPIOs here? We have to say if the GPIO is going to be for outputting stuff or to input stuff. So if we want to save something, control something, it's output. Yeah. We're trying to control the LED, so it's output. But if we're trying to sense something, it's input, and it's that. Digital write. Okay, so if you check out here, let me put the image so they can see too. Okay, this one. If you check on this side, it's written digital, right? And this is analog, right? Digital PWM, analog in. It's not that relevant, but some of the GPIOs can only be digitally controlled and digitally sensed, and some can be analogically sensed or controlled. You remember the difference between analog and digital?
I mean, in this context, no.
Okay. Digital is if you imagine a clock, the clock ticks, right?
Right. I mean, you're talking about the broader spectrum of the broader meaning of analog and digital.
Yes.
Then yes. Okay. Yeah.
Oh, cool.
I understand the concept at least. Then don't know if I could describe it as well as, but yeah. Okay. So analog. So I take it we're going to use these things and we're going to connect the little what did you say they were called? Jumper. Okay. Yeah. So I guess you can with the digital. I'm just guessing here, but maybe you can simulate those jumpers, or do you actually need to have them there anyway?
I need to have it.
Okay.
I need to have it. But
I was dead wrong then.
No, we're just saying that the function that we had here, the digital write, it's just a function that we use to write digitally. So it's either on or off.
Oh, okay.
But analog write, we can write, I want 75% in, so you can dim the LED. It's the difference between writing things digitally. It's either on or off. And analog is, I want 70% power, 20% power.
I see.
Cool. And some sensors are also like that. If we have a light sensor, it can be either on or off. A switch, it can be either on or off. And a light sensor can be, it's this much light.
Right. You can like a dimmer.
Yes.
So you could, yeah, okay. It's like a difference between a switch and a dimmer, basically. Okay.
Yep. Let me just read. My man, e aí meu filho? É pra digitar em PTUBR. Vou só tomar um banho e volto. We'll do English this time, Rodrigo. Okay. And next, on the... Are you cool, man?
Yeah, I'm cool.
It's fine. Is
So
there
far, so
something
good.
not understandable yet? These things are going to come together eventually.
Yeah, so no, so far so good, I think.
Cool. We're going to move to the circuit part in a
Cool.
bit. Okay, but in the loop, what we do now is we say print line, serial print ln is print a new line. And we say to print oi in that new line. I'm just showing you this sketch because it has everything you need to light the LED. See the tangents? I should just... Anyway, I was going on a tangent.
Sorry. Okay, I wasn't following the tangent either. So, but this is just a way, like when you use a console login code, just to make sure it's working, or is it serving any other function?
It's just that you just console log stuff. You know, that was the first line on the loop. Okay, this is the most useful one. Console log to debug everything.
The old poor man's debugger.
So we print a line. We delay is waiting. We wait 1 second. We write the digital. We write digitally the test LED to low. Remember that test LED is the number 13 there. You know. So if we write it low, what does it mean? We'll do to the LED.
We're going to give it a lower not output, I guess. I mean.
Yes, a low output. Okay. So it will be lit or unlit.
I would say unlit.
Yeah, cool. we turn the LED off, we wait 1 second and turn the LED on. So since this will loop, we will write again, wait 1 second, low, and turn off. Wait 1 second, turn on. Right? Turn off, turn on. Cool.
Okay.
Cool. I think it's cool for me to run this. We'll just connect the Arduino here. Took me a second to figure that out. So I connected the Arduino there. If you go on ferramentas, aka tools, you can see there is placa node MCU. Up. Yes, there. If you choose Arduino Uno, yeah, we're just setting the board to the one we want, because different boards have different programming ways, you know. So we just chose the proper Arduino. If you go on tools again and see there port, choose the country, is the one it detected for the so it detected for the Arduino, the 13, and if you run that, if you click on the check mark, it will compile the codes if there is anything wrong. We're good, and then you can click on the arrow.
Which one?
Besides the check mark. Yes, cool. And this will upload the code to the board.
Oh, cool, man.
Loaded. Okay. So if you look here, the LED 13 is this built-in LED. We can use it for debugging, you know. So instead of you having to connect, we can use this one that is already connected just to test things quickly. Okay. But the 13, the GPIO 13 also connects that, so we can pull that signal out. Do you see?
No. Could you go back?
For sure. So we have all of the GPIOs, right? 0 to 13.
Yeah, and right now we're writing to number 13, right?
Yes,
okay.
yes. But
I didn't understand the connection you were trying to make with the what did you say this was called?
The proto board.
Yeah, proto board.
Oh no, I'm just saying that this LED is already connected properly to the GPIO 13, so we don't have to connect it just to test some stuff, see some stuff happening. You know, so we are doing that. We turn it off, wait 1 second, turn it on, wait 1 second, turn it off, wait 1 second, turn it on. And if you go on tools again, click on monitor serial monitor, we wait a sec. Oh, you have to choose 9600 speed. Remember that we set that up on the beginning. Cool. There we go. It says oi every 2 seconds. You know, it's what we said there. Monitor serial, just tell what's going on the serial connection. Cool. Pretty easy, right? Nice. So now you know how to, you have all the functions that you need right now to light up an LED. If you go on the folder again, there is a, this, if you go down, okay, so go on this here. Cool. This is a circuit diagram of how we are going to connect the LEDs to the Arduino. I will connect here. Can you try to build that circuit? I think.
Yeah, let's get it. I mean, cool. I'm gonna need some supervision, but we're gonna give it our best shot.
Oh, just a second. Let me put
so
the chair back.
Should I should just take these. I keep forgetting the names. I don't know why. Jumper. Yeah. So we're gonna do exactly as it's being shown there.
Yes.
Okay. Now you have like little icons for the LEDs. I assume over there, right? Is that what that is? What is that yellow? Sorry, maybe this is a dumb question, but what is that yellow, green, and what am I?
Sorry, I forgot. Ah, yes.
Yeah.
Here.
Sorry. Yeah. I'll just open these presents. Oh, I'm done. I thought the opening was under here.
See, we have different colors. Hell yeah, baby.
Okay.
See?
Should I just spread them around?
Yeah. I will just grab the battery. Just a second. Oh.
I feel like you could sell these as cyberpunk earrings. People would go for them. What do you think?
Cyberpunk. I bet somebody has done it before. Something that lights up, has the battery there already. Cool. So here's the proto board. You have the jumper cables here. Try to build that.
All right. Are the color codings important?
No, not really. They have different lengths, but it's not that relevant.
Can you zoom in a little bit?
Oh, remember the LED we saw before with the different terminals, the negative and the positive?
Mm-hmm.
So this black wire here is connected to GND. It's ground, so it's negative.
All right.
Okay. And this is the GPIO out that we talked about. We had the 13 here that was lighting up the LED. So this one is negative, and this one can be positive. We can pull it up or
I'm
pull
a little
it down.
lost here. I don't know. Can you explain a little better the concept of ground and what is the relation with positive and negative that I should be considering that I am not?
Okay, there's a good point. So if we take the LED and put one side negative and one side
it's
positive.
about it's about the signal it's receiving to know if it lights up or not.
Yes.
Okay,
yes.
okay, I get it. Yeah.
And the signal is not something. It's the weird signal that does a frequency. No, it's just like you taking the LED and connecting to a battery.
All right.
We're just connecting the two sides to positive and negative, and it lights up. Okay. So this output here can be a positive if we say that digital write high, we put it as positive, so the LED lights up. Okay. So we are connecting this terminal to the negative, and all of these connect together, right? And we are putting this side to the positive. So one side of the LED will be positive when we write digital the pin high. So this will be connected to positive, will come here, and this will be negative that we connected to this one. Okay, we're going to, I'm just trying to explain what's going on.
Right. Okay.
because there is
so
3
far-
and it looks very complicated, but this guy here is a resistor. It's just because this is a very high current. We are putting this just to make it more
All right. Okay.
sustainable for the LED. But we are basically connecting to positive, connecting this to negative.
All right.
It's just a
okay.
more complicated way to do it.
Mhm.
Cool.
All right. So should I just go in and do exactly as it's described in the diagram?
Yeah.
Okay.
It's pretty self.
Is there a specific order? Is that important at all to do things?
You just have to remember which LED color is connected to which port here. So if you want to do red, green,
I
and
feel
blue,
you. Okay,
it's
yeah.
just connected to different ones. While in the meantime, I read here. Só tomando banho em volta. Hey bitches. Hey Rony. Hey dude. Stream today, Rodrigo. I've already streamed today. Oh, hey, Carol. Cool.
Okay, so walk me through this one. Now I should be putting this jumper here, like this. Is this okay? Oh, I guess not.
Oh, I forgot to talk about one thing. There is a polarity between the sides of the LED. So one is necessarily positive, one is necessarily negative.
Mhm.
And you can only tell by the interior part. The bigger side of the terminal is positive and the smaller is the negative.
Sure. Okay, I see it.
So you should leave the negative always to the left or always to the right. Between all of them, you decide. It's
Okay.
just
I'm gonna put the positive one to the left.
Cool.
It's a cool one. Explains why they weren't staying at the same. Never mind. Okay. All right. So
cool. Going back to the guy here. So on the diagram, they did just like you. The bigger part is to the left.
Cool.
So you can use the same direction.
Jesus. Am I doing this right? This doesn't seem to go in. Am I messing up?
No, you just,
Is it just
twist it
supposed to-
around, maybe.
Hold up.
It doesn't have to be the one directly below
Oh.
it. It can be on any. No, it's good. It can be on any one on that vertical line. So
Sure,
if
okay.
one doesn't fit, you can go down if you want.
Alrighty. Coolsies. Man, I could have gone. This is dumb. I'm being dumb. Hold on. Why don't we actually color code them,
I should have had a green one. Oh, there is a green one.
There is a
Cool,
green
cool.
one, yeah. It's almost as if, we thought this out.
Yeah, I sure did think this out. I know there was going to be a green in there somewhere.
Alrighty. Yeah, sure. Alright, so we got the red, the green, and the yellow. Now, we're gonna connect them. We are going to connect them to 9. Is that what
Yes.
I see there?
9.
I'm a little blind, you guys. Just bear with me.
I'm trying to search for a informative GIF here.
Anyway. How are we looking?
Dude,
Cool.
all good for now. Nice. So we connected the positive side to the GPIO port,
Mhm.
right? And now we have to connect the negative side to the ground here, to the negative. Ground is the negative one.
Mm-hmm.
Okay, so we just take the ground from the Arduino and put on this blue row. So remember, all of these are going to be connected. So all of them are going to have the negative from the Arduino. And we just send them to the LED. Okay, but we have we're going to we're going to pass through a resistor just because of that 5 voltage difference that I told you about. The resistor will pull it down to 3.3, sort of, kind of.
Properly framed, I think so. Okay. And can I just GNR?
Yes, GND.
GND, yeah. Okay. All right.
Cool.
So that last part you talked about, are these little things?
Yes.
That I need to put between those 2 lines that are connected vertically.
Yes.
Sorry, this might be another dumb question, but can I just put them anywhere that they have to be connected to the negative side of the LEDs?
Yes.
Okay. Shoot, I really put myself in a corner here.
You can move it around if you. Oh, yeah. By the way, the tweezers for that.
The tweezers. The tweezers are going to be handy for sure. Not now, but maybe later. Okay. So. No, this has to be on negative, right? Like this.
Yep.
Damn, dude, I did not expect. I think I need glasses. I really think I need glasses. Okay. There's another one here. There we go. Cheskis?
This is good. Let me just see here. Oh yeah, do you know what What is a Victoria Arduino? No, I don't know, man. What is that? Sorry. So what we are going to do here is basically this. So if we have a battery here and we connect one side to the LED and connect the negative side to the LED and the positive side on a switch, it will only light up when the switch is on, right? Because if it's off, it will not connect. And when it's on, it will connect and the LED lights up.
This is a hella cool GIF you found here. It's very...
Took me a while. I was very focused on it.
It's very easy to digest. Yeah.
So this makes sense, right?
True.
No problem with that. What we are going to do here is basically the same thing, but instead of having that switch that turns on and off, what will turn on and off the switch will be the Arduino. Okay, so in the program we can say switch this GPIO on, switch it off. Okay, so it's basically the same thing. Remember that on this program here, we set the test LED to be 13. We can now you go to the programming chair. Remember which I will turn on here. You remember on which GPIO port did you connect the yellow LED?
I think I went by the diagram.
Yep.
I think I followed that correctly. So, does it say here? Jesus.
It's on
10? 9?
9, yes.
Is it?
Yes.
Yeah, it's 9, sorry.
So if we define the test LED as 9, that one should light up.
Okay, should it be like this or like this?
Yes, like that.
Okay.
I think now you can send. If you just send as well, it will compile and then transfer.
Oh, okay. What? Okay, we got our first exception.
The port, check if the port is the same on tools. boy.
Oh, was it poorly connected or something?
I don't know.
I don't know if I did a good job with that.
You can close the window. Try open again.
This window?
No, you no need to close. Just open tools again. Yes, unclick one of them. Can you close this monitor? There on tools again. See if it's dang. Just close this. Control S to save the sketch. Close and open again. Must be fucky, man.
I thought I had the armrest and I went full confidently into it.
Dang.
All right. Okay, so okay, I think it's good.
Cool. By the way, can you leave the chat open there on the bottom left?
Sorry, what?
Gramadinho right down here. Cool. Then we can read. Now try to send the sketch again.
What is this software we're using, by the way? Is this
It's
something that comes with the Arduino when you buy it, or do you
This
have
is
to-
what's yes, it's the Arduino software.
All right.
Arduino IDE. Boom! Done.
Hey, look at
We
that,
have a
it's
lighting
working.
up LED, baby. Cool. Pretty easy, right?
Yeah.
Do you think that now you could light up all three of them with the functions you have there? Could you light all of them up?
Yes. Can I define test LED as more than one value, or do I have to define two others? Like this? Can you give me the numbers there, please? Because I'm sort of blind.
You can see on the picture you connected correctly.
Right.
Everything is
You're right.
the same.
When you're right, you're right. Was it? So 7, 6, and 5.
It's 6 and 5. The other two ones.
Okay. Is this okay?
Oh, I see what you mean. No, you have to define different variables.
Okay, yeah, that's what I. Test. Can I change? Can I refactor this to like yellow, red, and blue? Blue? No, green. So this one was the yellow one, right?
Yes.
Here we go. Which one was red again?
It was the 5.
And
Blue is the 6.
blue isn't no green?
Damn, it's green.
6. Alright.
Cool.
Video save, and now we're gonna have to use these variables in the define and the setup. And does this take more arguments, or
No.
what do I do here?
You have to define. You set the ping mode for the other ones with the same function.
I feel you. I had already shoot.
What up, Chief? What you doing?
Green.
Graham.
It's a very green outlook on life. All right. So same here.
Yes. Green.
I'm having a hard time writing green correctly for whatever reason. Okay, so we got the red here, and just so it doesn't happen again.
Graham.
Cool. All right.
By the way, on the IDE you have Control T to format everything. It's very useful.
Dope.
Cool. Now, what do you expect to happen when you run the code?
Hold on, let me see if I forgot something, because this felt too copy pasty to be correct. I don't know. shoot, I don't know. I think from the logic of what we had before, we didn't really do anything else. Do we need to hold on?
Remember what? Tell me what the setup functions do. Each one, do you remember?
Setup functions.
Yeah, the functions
Okay,
that are
so
called in setup.
I don't know if I can explain them as well as you did, but
Just in and whenever, whichever way,
oh,
it's all good.
do they need each an individual serial?
No.
Okay.
Serial is the general. It's by the microcontroller.
All right.
We're
Yeah.
using
Okay,
just
I
the
got it. I can't remember what pin mode was, man. I'm sorry.
Pin mode. Remember that in one GPIO we can send the signal out, or we can receive it in.
Oh, right. So we're telling it we're going to need it to do something. So we're saying by using test yellow, we're giving it the GPIO. Is that right?
GPIO. Yes.
Yeah, GPIO, and we're telling it that it's going to do something, right?
Yes.
Okay,
yes.
so that's what pin mode is doing.
Yes.
Digital write is regarding to that. Oh man, I can't explain it.
It's the switching.
The switching, sure.
The
That's a good way of saying it. Yeah.
If we say low, what does it mean?
It means it's not turned on.
Yes. Cool.
Shoot.
We turn all of them off
Mm-hmm.
for the start.
All right, man. If there's a catch here, I'm not seeing it. I think it all seems okay from what we've seen so far. So can I just? Shoot. Oh, there it is. Cool.
Ooh, yeah. So it's just the same thing we did before. We wait 1 second, turn off, wait 1 second, turn on, wait 1 second, turn off. And that's what it's doing for all three of them. Cool, right?
Mm-hmm.
Now, do you think you could turn one of them at a time?
I mean, I could just let me know if I'm oversimplifying things, but can I just delay it between each digital write? Could that work? Shoot. Oh dang. I'm not sure this is gonna cross that bridge when we get to it.
It's about experimentation. You know?
Yeah.
It's very hard to
try to predict what the code's gonna do when you've never seen it before. So yeah, I think okay. Let's see. Shit. Did I save?
No need.
Yeah,
every time that you send, it saves. Cool. All off. One on.
Ah, it's very Christmassy, isn't it?
Cool.
Cool.
Very nice. And by the way, man, that's very good.
You know,
very
just
impressive.
just doing
Honest
my
man
thing, you know,
doing-
just feeling it.
Honest man doing honest work. Now, if we try to light only one at a time and go 2 2 2, yellow, green, red, yellow, green, red, yellow, green, red. Only one lit at a time.
You meant like in order?
Yes.
Okay. Oh shoot! What am I missing? Ah, there it is. Is it working as expected? No.
We should have only one lit at a time.
Right. Should it decrease the delay?
It's more of about the switching. Remember that remember that when we say digital write, we are only changing the switch. God damn. So if let's see what the loop does. So serial print ln, not that relevant. We wait 1 second, turn the yellow off. Wait 1 second, turn the green off.
Oh, I
wait
feel
one
you.
second,
Okay.
you know?
Yeah. I feel you. Yeah. think I. Is that right? Shoot. Hold on.
Now it's
There's an order here that I'm. Okay, so we want yellow to turn on first.
Yes.
So we're gonna give it a high. And then we want it to. No, okay. So we.
Nice. I see where you're going.
Oh,
Yeah.
yeah.
Smart man doing smart things.
I'm honestly impressed with myself because I thought I was gonna freeze up by being on stream. I'm sure it will happen eventually, but so far so good, right?
I think that at some point you get kind of numbed to it. It's not that relevant to being on stream, at some point.
And something's off here. Dang it! What did I do wrong? Is it working? No.
It should
because I got no. Wait. It should be green first. Okay.
Yes.
Shoot! Didn't even notice.
I think it misses. It's missing a delay.
Mm-hmm.
See? There is one too many delay at the end.
Copy paste master over here.
Have heard the expression "bibbidi boppity"? Your code is not my problem.
I saw a very offensive version of that meme once, but I'm not gonna say it here on stream. Damn it!
I think you pasted it between the yellow ones.
God. See, I was bragging about not freezing up, and what happens? Okay, so yellow. Now we're going green.
Green.
There we are. Took a few tries, but we got there.
And it loops. Cool, man. Now we have full control of LEDs, and do you understand everything that is going on?
Yeah, so far, yeah.
Cool. And then I think we got the first half. We can control LEDs at will. Cool.
We are gods.
Now we worked with the pin mode output. Now we're going to work one with the input.
Mm-hmm.
Cool. So if you open the folder again, you see you go up. Nice. There is that IR module circuit diagram. Cool. Now if you could do that one. You don't need to undo what you did there. Mm-hmm. You can just put them together. By the way, this is the sensor. It already has jumpers connected to the end, so it's easier.
Oh, all right. So, okay, so if I'm understanding this, the gray one is the negative and the red one is the positive, or is that just random colors?
It's the same order. If you look at it like this, it's the same color. Boom. So sorry, not colors. It's the same order.
Order, sure. Yeah. I felt you. I got you. I've been using the expression "I feel you" so much that I use it incorrectly all the time. I felt you. Sounds oddly sexual.
I felt you, baby. If there is not enough wire, you can strip them.
Yeah. Apart. Okay. I was afraid of doing that, but it's certainly gonna help. Mm-hmm. Cool. These two. frame. I think so.
Cool. That's it.
Now what?
Nice. So remember that I told you that. Okay, we can go back to the coding terms. Remember that I said that on the cheat sheet there was the code that helped with. Could you close the window, man? It's cold as heck. Dang.
Got
it. Remember that I said that there was code to handle the hexadecimal and communication between them. If you open the Miguel's cheat sheet, there you go, that one. All good, all good. So you just have to copy and paste from start to end. No, not, sorry, I expressed myself bad. It's from start until the line comment start until the comment that says end.
Oh, I'm sorry, yeah, okay.
I didn't say it properly.
I should have noticed that you were saying you should just copy everything. If you meant I was supposed to copy everything, I think you would have said it a different way. But anyway.
You have to put on the start.
On the setup?
No, before everything. Yes. Cool. Then, okay, I will, on the header, we are just declaring, including a library, defining some stuff, defining some variables, and creating some objects. What the heck? So the IR receiver, it's the IR receiver. You see that first IR there. The code results is the object that creates that gets the results from the sensor. This is just a second.
Go ahead. Kind of sprinting the cats because they're misbehaving.
So this is just library usage, you know. I'm just preventing you to spend 15 minutes reading the library and understanding how to use that IR remote. You could totally do that, but it's just to be concise, you know. So all of this is we're going to, if you scroll down, we are declaring some functions, decode hash, get key from IR sensor. Is that what I said? So is that part that I said? Take the results, transform the hexadecimal hash, and then down there is change based on the hash to the codes that we are getting on the controller. Okay, it's pretty busy and boring stuff, you know, but understandable. Cool. So if you go back to the cheat sheet again, if you go on the setup, it's down. There is the two lines. You see, enable IR in and blink 13. You just have to copy the enable IR in and blink 13. So you are remember ping mode, where you said output. Since we have this library, the way that we define that on that GPIO we are having this is by saying enable IR in. Cool.
All right. So should I put it on the setup before anything else?
You can put before anywhere. Okay. Cool. Nice. And the way that you get that you get the value from here is by using the function. If you go back to the cheat sheet, and you go down on the loop, there you go, string result get IR sensor. So if you just copy that, go in our loop, yes, and instead of printing OI, paste the result, just set the variable and paste and print the results. Cool.
Coolsies, and it's not indented properly and it was giving me a headache. Alright.
Nice.
Running?
bigger now, huh?
Mm.
It's a little bigger now.
A little bigger in size, you mean?
Yes. Still
Memory
loading.
size, sure, yeah. Could I get some water while we wait? I think it's cool.
A little odd. Shouldn't happen. We'll do this. Okay. We'll try to connect again on the port. Cool, cool. Just try to send again. Shouldn't take that long.
Hmm.
Cool. Could you open the serial monitor? Nice. Okay. There you go. So remember that we said enable the number here. Enable the blink 13.
I remember. No, I don't actually.
Let me just check one
Enable?
thing here. Oh, okay. It's so you connect the sensor to the reset pin there. You see, if you go back to the
maybe I misinterpreted the diagram.
yes, you see that it's connected to the 3.3 volts there, the red part.
Yeah.
Okay, so instead of the reset, I would just disconnect there and connect to the 3.3.
Oh, all right.
And it starts blinking. See? Because it's able to, if you go back to the code, the LEDs were not blinking because we couldn't get. Problem. The LEDs were not blinking, and the other part of the code was not working because we couldn't get any reading from the sensor. So the code was stopped there. We connected, it started running, it saw nothing, and the rest of the code started working. It's pretty interesting, right?
Yeah, cool.
Connecting the sensor can allow. So if you open the monitor again, let's try to click something here. Okay, go there. Nothing is showing up. Pretty crazy. If you hold one of them, nothing is showing up. Pretty weird, right? So if we go back to the code and if we take a look, what we are doing there is we are trying to get the reading from the sensor, printing that result, waiting a second, turning on the switch, waiting a second, turning off, turning on, turning off, turning on,
She
turning
has
off.
the print maybe after the digital, right?
No, if you think about what delay does, is we stop the execution of any code for 1 second. So if I am trying to read from a sensor all the time, very, very frequently, I cannot stop the code. So every delay just prevents me from reading from the sensor. So for any reading to reach here, we would have to click the button in the exact second that the sensor is trying to read, you know?
Yeah.
So if we comment out the lines of code there.
You mean everyone, or every single one, or just the delays?
You can comment you can comment everything below the serial
I
print.
can find your.
It's right here. Boom,
Oh,
boom.
cool. Sorry, what you were saying?
Yeah, that we can comment everything out because it will be useful. Nice. Fast as fuck, boy. Nice.
So that is
exploded. Okay. You see that if you delete the output, the output grows really big again. That it's because we are printing even though we are not receiving anything.
Okay.
You see? So we should make a check before printing the result to see if the result is different than nothing.
Okay.
Programmer already knows his ifs and else's.
This should be enough, right?
Yes.
Shoot, man, I can't figure out your. Sorry. Huh? Okay, there we go. There we go. Actually. That's pretty. Is this okay?
Yeah. We go back again to the serial monitor. Cool. But clear the output. It's still growing. I think that it has to be result different than.
Okay.
Yes.
Null? Or
no.
Shoot, it's supposed to be.
It's that button. Yes. But
Crap. Okay. So if
it's double quotes.
Jesus.
Yes. Cool. Let's see again the monitor. Clear the output.
There we are.
Nice. Cool. Now let's see.
Let's give it a shot.
Okay, so we are receiving and we're not showing anything there. Let's think why. So this is a good opportunity to talk about this debugging. You know, it's very in hardware. In software is okay. You have the problem, so the problem can only be in one place in the code. You know, but oh no, I mean you can be on the server, it can be on the front end.
Yeah, but I feel it's always going to be something behind the screen, right? Like.
Yes. But just like there, where you have to try to narrow down where the problem is, here is the same thing. You have to narrow down where the problem could be coming from. So the serial monitor is the same. We got the output, even though it was empty, we were getting some output. So the serial monitor definitely is working and getting signal from the serial communication, the serial port.
So there's something fucky with the way I made that thing, right? There's maybe some cable or something.
Yes, it could be here. Yeah. That's a good point.
Who would have thunk?
So if we go up, and see the definition of the IR receiver port on the very beginning. Cool. We defined the receiver pin as the number 7. Right? If we see there, constant int receiver pin is the number 7. You see there?
Mm-hmm.
Okay. We'll check here, and is on the number 2. So I will give it. Pass it to the 7 one. Boom. Oh, fuck. Cool. Okay, let's see it. Hit it.
Well, would you look at that?
Booyah, we got him. So, but this was actually unfair because I introduced this problem because on the diagram, I think it was connected on the 2 actually.
Oh, okay.
But it's good that we got.
Let's check it. I mean, it's quite possible because those things
There
are
you
really
go.
small for my eyes, and maybe I made a mistake. But okay, whatever.
No, it was on the 2. It was my mistake. Sorry, or maybe it was just
That's just
supposed to put
it was all on purpose to create suspense. It's cool.
So we got the signal from the controller. We can control the LEDs now.
Mhm.
Do you think that you could we can light up the LEDs individually? You think you could set the LED, the yellow LED, to light when the button number 1 is pressed, the green with the button number 2, and the red with the button number 3?
Mm-hmm.
Cool.
I think so.
Cool.
Okay, so we're gonna uncomment this. Do we still need the delays, right? I'm just gonna uncomment everything.
The delay will just stop. We'll just.
Oh, this was just so for display purposes then? The
Yes,
delay?
for us
Alright.
to see them individually doing stuff.
Alright, so test yellow. We're gonna condition this bad boy, and if result equals what was the number? 1?
Yes.
1, and we're gonna do something. And what is that thing? That is the digital write.
Just remember that we defined the result as a string, so we should compare the results to
okay.
a number 2. Sorry, to a string 2.
Yeah, you're right. Call.
And
Okay.
also in C++, we also use double equals. Yes. Ah, fuck.
I'm sorry, it's just for visibility purposes. Okay, so are we good? Should we tell it to... Where the hell do I have test yellow height? Twice. Wait, what?
I think you just copy.
Oh yeah, right, I forgot. Okay, I thought I just written the condition around it, but okay. So we don't need this anymore. And what I was gonna ask is, should I go for, we just want it to blink, or should we, no, we want it to turn on when we click number 1 and stay on.
What do you want?
I want it to stay on.
Okay, cool. Remember that if you just send, it will compile, then send. Even though it's broken,
right,
it will not mess up the board.
Okay,
it won't
cool.
send broken code. Okay, so let's see.
Hey, look at that.
Nice. Do you think you could do the same for the other ones?
Yeah. Oh, you're right. We were supposed to do the same for the 3.
Yeah, but
All
it makes
3.
sense to try one out.
Yeah.
Yeah.
Okay, so 2 is going to be green. And 3 is going to be red. Alright, I'm going to press 2. Dang, what did I do wrong? Hold on. 1's working. Do we have a problem in the board again? Shoot, 3's working as well. Oh, okay, was it still loading? Am I that much of a noob?
We can look at the serial monitor. It shows the...
Right.
No, does it? Yes, it does.
Alright,
So
weird, can I... okay, but it's working.
we only saw the number 2 on the 3rd try.
Yeah. Can I restart this?
I can restart here. There is a reset button.
Is it good to go?
I think so, yeah.
Okay, let's hit the yellow one.
Cool.
Let's hit the green one. Red one.
Cool.
Alright.
Can you only light up one of them at a time? If you click 2, the other 2 ones are turned off.
Yes, I just need to conceptualize it. Okay, so if 1 is on, can I directly access that test yellow is, like, can I make a condition based on it being high or low? Can I get this?
This is a good point. No, but why? Why can't you know that? Because right in the beginning, remember that we said that pin will be an output. So we cannot, at another point, try to know what is the current state.
Cool. think so. Soon. So if we have one. Dang man, I'm freezing up.
So if you click on one, what do you? Let's start from the scratch. On the beginning, all of them are off, right? If you click on number one, what will happen?
Oh, okay. Never mind. I got it. We're gonna go with digital right, and we're gonna tell it to shut off every other color.
Yeah, let's go.
Yellow. Red, green. Now same here. Yellow is going to be low, and green is going to be low. Shoot. Some ugly ass code. Okay, here we go. Oh, I think I clicked it too soon. What the heck?
What the hell?
Hey, look at that.
But you are clicking like the yellow one. Nice. Green. Hell yeah, man.
Got it.
And the last one I want to know, if you click any other key besides the 1, 2, 3, could you turn all of them off?
Okay, so we're gonna use maybe another condition if I'm not being too complicated here. If result for different. I'm sorry, I defaulted back to Portuguese for a minute there. I think I'm gonna be okay. For different. Shoot. Or where's the or? To shoot. 2 or 3. We're gonna tell it to do what exactly?
Turn all of them off.
Okay. Yellow, green, and red.
Low has to be.
Oh crap! I didn't even notice. Yep. Here we go. What? It's what? The OR condition doesn't work like I expected it?
No, it doesn't work like that.
Okay.
You can do it. It's just not that way that you write. You have to do result different. Different is only one equal. It's not equal.
What the freak? So switch?
Not really. You can say or, but it has to be result different than 1 or result different than 2.
Oh, okay. I see. Okay, it's a bit of quite the ugly code here, but just for convenience sake.
It works for me.
That's just actually. How's this looking?
Yes, just missing a parenthesis at the end.
It did not break. Very nice.
Easy.
Okay. So number 1.
going on?
I do not. It's not turning on.
Click.
What did I?
Click.
Oh crap! Wait.
What do you think is happening? What is happening here?
It's immediately turning off
Yes.
right as I try to connect it, and it's happening to all three of them, which makes me wonder that maybe this condition shouldn't be done. Should we be verifying this at the beginning? Is that why this is happening?
So you are focused on that condition because that's why you think it's happening.
Yeah.
So we are always entering there, right? What do you think is happening on the code?
Okay, I'm not sure. Let's take it step by step. So here we are checking if the number is 1, and he's gonna turn the yellow one on. So he's gonna do this condition first, right?
Yes.
Then he's gonna do this again. He's gonna do these two, but it's gonna check that it's not number 2 or number 3, so it's not gonna go inside him, right?
Yeah.
But here, since it's different than the other two, I think I have to make an if. I have to make the ifs individually instead of the ors.
But you see that it immediately turns on. Sorry. It immediately turns off.
Yeah.
Right. So in the condition 1, let's say if I click the 1, would it enter there?
Would it enter this one?
Yes, that condition.
Oh no. Would it?
We can. By the way, a great way. How do we debug this kind of stuff? We just console log that shit.
Oh right. Okay. So you want to console log the result after each.
Yes.
What was the name of the function?
Serial dot print ln. Yes. Cool. No, you don't have to do it everywhere. It doesn't change.
No, right? Yeah. Right. Okay.
What's going on?
I feel like it's because it's doing all the conditions at the same time. Maybe it's recognizing that it's 1, but it jumps to the next validation and checks that it's different than 2, so it turns itself off. Is that what it is?
No, it only enters if it's not 1 or not 2 or not 3. If it's 1, it will not enter.
I'm drawing a blank. I can't figure it out.
Try to clear the output there.
Okay.
See what's happening?
No, not really. What's
clear
happening?
Clear again. Boom! We get a bunch of lines.
Right.
Of empty lines. If the result is empty, does it enter that condition?
No, it does not.
It does.
Wait, if it's empty.
Yes.
But we're not. Oh, okay.
It's different than all 3 of them.
So as it's behaving now, it's different from every single one, but it's recognizing that it's not getting a value. So we have to check if it's null. I don't.
Yes, that is exactly it. We have to check if it's null. Because the result empty is also a result. Remember that in the loop we are running all the time. And if we send get IR code and it returns empty. Empty is
it is an
something.
input. Yeah. Okay. I feel you. So should this fix it?
We should. You were saying result different than. Yes, I think so.
Let's check. Crap. Ah, damn it.
So let's think again. If the result is different than empty, or different than 1, or different than 2, so if it's empty, the result is not different than empty, but is different than 1 and different than 2, so no, that condition will not do, because empty is different than all the other ones. So we should, instead of an or, should be an and.
Oh, yeah. Okay. Damn, man, you're right.
But I
Like
think
this, you said?
there should be just an if above, you know?
Oh, yeah. That would be...
X Games.
I was trying not to go there, but of course we had to go dank on them. Okay, so if... Give me a bit of this little shit. Okay.
We could also put a parenthesis around that big condition and put an end, result different than empty, but it's just...
Sorry,
I think it's easier to put an if around.
Okay.
You know. The code should be inside the second.
It usually is, isn't it?
It helps out.
Okay, we good?
I think we good.
Okay.
Cool. Okay.
Okay, number 1. And it's not working yet. What? What are we missing? Damn it.
If result is different than empty, if results... we are not running there all the time, but we are turning them all off. Okay, let's see up if there is something funky going on.
Up where?
Yeah, no, on the beginning of the loop. More up. Nice.
Oh, the loop. Okay, the function.
If result, we already had.
Oh, okay. So, if result is null, we print that result.
I think that why are we turning all of them off? That's odd. Try again. If you click the 1. Okay. The 2. No.
Okay, it's first of all, it's doing something strange. It's reading 2 inputs, and I only clicked once, and it's having that behavior all the time. So somewhere in this loop,
we're entering the number and the one down there, right?
Sorry, you mean where?
If I click, we are having 2 debug logs, right? With one button click, the number is written twice, right? So it's written up there on this, and written down here, right? So we are entering those 2 conditions.
So in here do we still need this?
I think we could pass all of that up there.
Yeah.
You know?
Yeah.
Oh no, actually
or just put the serial print down. Yeah. Okay.
Oh, we already have it, right? So you had already put
point. Yeah.
Okay, so let's say I click on 1. it will enter the if result equals 1. And will it enter the second one? Is it different than empty? Yes. Is it different than 1? No. Is it different than 2? Yes. Oh, okay, so it will enter there.
You're right. It should be and, not or.
Yes, yes.
Gosh.
Those damn conditions.
How's this? So it won't. Yeah, okay. I have high hopes for this one.
Okay, let's see. Oh. Oh.
Oh,
and now something else.
Yeah, something else. Okay, it's still weirdly registering 2 inputs.
No, it makes sense.
Is it not?
Oh no. Okay, let's see.
1, 2. It's not. Why is it not logging?
Because we only put the log inside this last one.
Anyway, let's just see if it works, and we'll clean up the code later.
Yes.
Look at that! Hey!
Cool, man.
Very cool indeed.
That's it. That was my last challenge.
Very nice.
Do you think you understand what's going on? It's funny how we think like, wow, this is I don't understand this hardware stuff, but it's very logical, you know?
Oh yeah.
It really respects the conditions.
Yeah, man. I mean, it really is like demystifying the thing. Like, I had no concept of how this worked. Of course, we're just doing something very basic. I'm sure, like, if we were trying to program something a little more complex, I'm sure it would have a lot more components and things to it. But I have to say, for my first experience, this is I'm so dumb. Yeah, it was a lot more accessible than I expected, and it's very cool to see. Like, my fascination with this whole thing was, like, it's cool to write code and see things appear on your screen, but to have things around you, like, change state because you told it to. It's very X Games, very X Games indeed.
I think the
hell? Where should I put that print? I'm a little burned out.
It will print anything that is not 1, 2, or 3.
Oh right. Okay, so I should put it before everything. Anyway, this was just for the benefit of the viewers.
Do 100 plus. Click on any other thing that is not 1, 2, or 3.
What?
Open the serial monitor. Click anything that is not 1, 2, or 3. No.
Mm-hmm.
It's not recognizing. Try to aim it.
Oh, no, it did. No, it did. Okay.
You know?
Very nice.
Cool. Nice, man. So, is there any parts of the code that you don't really understand?
No, not really.
Cool. Do you think you could make it do more complex stuff if you had time and a need? You know, if somebody said, oh, now I want it to do yellow, yellow, green, 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 yellow.
When
I
want
click
certain combinations of 2 colors to be, I think specifically like just messing with 3 LEDs, I think it would be pretty accessible. Yeah.
Cool. So you said that more complex stuff is probably more complicated than this. Man, it's pretty much all this.
It's
just
pretty much life, right? I mean, it's pretty much life. When you start something, it's like, oh, it's so daunting to imagine like all the possibilities that you can do with a certain know-how. But it's like, you gotta start these little these little layers. But sorry, I was on a tangent here. You were gonna say?
No, it's just it's more complicated data in and more complicated output out.
Mm-hmm.
You know, so instead of just being IR sensor is okay, you're getting data from all these different sensors through all this time, and you're making more complicated stuff do different things, but it's all that input in, output out. You know.
Mm-hmm.
Cool.
For sure, man.
Nice, man. I appreciate the time.
No, man. It was I appreciate this. This was so cool, so much fun. It's like it helped me conceptualize a lot of things that I had no freaking concept of, and it really doesn't seem far-fetched anymore, you know.
Mm-hmm. Nice, man. I think we are going to close the stream then.
Oh dang.
MC, I had something to say. No, all good. I do this, we are ready to start. So thanks everyone for watching.
Thank you for joining our stream and putting up with my slow resolutions.
What? We did it.
Thank you for how long?
An hour and a half.
Cool.
So quick.
All right.
Thank you, Rodrigo.
Thanks everyone watching, and thank you, Kaina, for having me. This was really cool. I learned a lot today.
Cool. Bye bye guys. If you just click the mouse. Bye.
Bye.